Okay, Assalamualaikum and hi everyone. So today we are going to start chapter 9, random variables. So now as you can see from this, saya dah bagikan kepada dua, which is we have two main things in chapter 9. We have discrete random variables and continuous random variable. Okay. In discrete random variable, as you can see, we have probability distribution and also cumulative distribution function. And for continuous random variable, we have probability density function and cumulative distribution function. So all these things are different. Okay, so tips untuk chapter 9, when you see the question, the first two things that you have to identify is either discrete or continuous, or probability distribution, probability density, cumulative distribution or cumulative distribution function. Okay, dua benda yang kamu kena identify. So soalan kata discrete ataupun cumulative distribution, ataupun soalan kata continuous, probability density function. So that's the two things that you have to identify. So for this video, we are going to focus on this part only, which is probability distribution untuk discrete random variables. So as you can see here, I have highlighted that is the definition or main thing untuk probability distribution for discrete random variable, which is the summation of px equals to x is equals to 1. Okay, so let's just get started. Okay, before that, what is a random variable? We know that a random variable can be discrete or continuous, as I explained earlier. So what is discrete? Discrete means countable. Okay, countable. So let's, like for example, we have number of cars, number of houses, number of books, and so on. So if you want to represent that in number line, we have, let's say this is your x, we have 1, 2, 3, and that's going to be equal. Okay, x equals to 1, x equals to 2, x equals to 3. So however, for continuous random variable, contain in one or more intervals. So dalam interval lah. Okay, example height, time taken, income, and so on. So if you want to represent that in number line, it is gonna be, we have 1, 2, 3. Dia akan jadi x is between 1 included and also 3 included. Okay, so this one is x equals to 1, 3. Okay. Alright, so kalau discrete, dia akan equal. Kalau random, kalau continuous, dia ada inequalities lah. Okay, so let's see the difference. State whether the following random variables are discrete or continuous. We have number of handphones. Obviously, this is discrete. We have time taken to finish a task. So this is continuous. And we have a volume, the volume of petrol. This is continuous. Okay, so discrete boleh dikira x equals to something, continuous dalam interval inequalities. Okay, so now let's focus on discrete random variable. Okay, refer back to the checklist. As you can see, we have three main things on probability distribution, which is we can represent the data by using table, function, and also graph. Okay, for probability distribution, we can represent by table, function, and graph. So let's see. Okay, probability distribution of a discrete random variable. Okay, macam saya cakap, bila kamu tengok soalan, there are two things that you have to identify. First, is it discrete or continuous? Second, is it PDF or CDF? Okay, so that's it. So here we have, if x is a discrete random variable, then which takes the value x1, x2, x3, and sampai xk, then px is equals to xi. Okay, I tu berapa kali lah. So, okay, so let's say if we represent this, we can write it as x equals to xi is equals to, px equals to 1 plus px equals to x2 plus px equals to x3 and so on sampailah px equals to k. If you sum up all that, you will get 1. Okay, as you know that the total probability is equals to 1. Alright, so therefore, x is known as discrete random variable if the summation of px equals to x is equals to 1. Okay, discrete random variable, summation of px equals to xi is equals to 1. So that is the very important definition. If the question said show a discrete random variable, okay, probability distribution discrete random variable, that is what you have to do. Okay, so as I said earlier, probability distribution can be represented in the form of table, function and graph. So let's see in table. So obviously you need to have your table. Okay, saya ingat sikit tablenya, but that's alright. So let's say we have 1, 2, 3. Okay, let's say this is our x. Okay, this is px equals to x, which is the probability. So let's say your x is 1, 2, 3. When x equals to 1, the probability is 1 over 3. This one is 2 over 5. This one is 4 over 5. Sorry, 4 over 15. Notice that if you sum up all the probability, you will get 1. Okay, you have to get 1. Alright, so if you want to represent this data in function, that will be like this. Px equals to x. Okay, so this is the symbol for probability distribution. Px equals to x. So in function, kita akan lukis macam piecewise function. So that will be 1 over 3, the probability. And we have 2 over 5. And we have 4 over 15. And this will be your x. X equals to 1. X equals to 2. X equals to 3. Okay. Okay, so if for graph pula, the graph will be looking something like histogram. Okay, so yang paling kecil antara sini ialah 4 over 15. So ikutlah. So here will be 2 over 5. Here will be 1 over 5. 1 over 3. Here is 2 over 5. Okay, so here we have 1, 2, 3. So when x equals to 1, we have px equals to 1 over 3. Okay, when x equals to 2, we have the px equals to x is equals to over 5. Right. Give me a second. Okay, bolehlah tu. If x equals to 3, we have px equals to 4 over 15. So your graph for probability distribution for discrete random variable will be looking something like histogram. Okay, please take note this before we continue to the next one. Alright, so let's see the example. Example 1, let x represent the number of tails obtained when 2 fair coins are tossed. Okay, sebenarnya ada 3 benda yang kamu kena tahu bila kamu baca soalan. The first one, macam saya cakap, we have to identify it's either discrete ataupun continuous. So for this question, this is discrete random variable. Okay. Second one, it's either probability distribution ataupun cumulative, PDF ataupun CDF. So this one, the question said probability distribution for x. Okay. And sebenarnya the third thing, you have to identify your x. Okay. This question said your x represent number of tail obtained. Okay, tails obtained. So back to the chapter 8 probability, we know that if we have coins, it's easy for us to do the tree diagram. The question said 2 fair coins are tossed. So we have head, tail, that is the first toss, and then head, tail, head, tail. Okay, so that is the second toss. Okay, and then the outcomes, the question asks for the number of tails obtained, so that will be HT, and X represent the number of tails obtained. So outcome kita ada, let's just list down everything. We have HH, HTT, HTT. Okay, that's the outcomes, but our X here is number of tails obtained. Okay, so now let's represent our data, what we have here, our probability, by using all these three. Let's see the function first. Okay, table first. Okay, so let's see the function. Okay, so the function said probability distribution for x equals to 1 over 3. Okay, so table first. Okay, so obviously we need to have our table. So as you can see, our x is number of tails obtained. So you can see that we have 2 tails, 1 tails, and this one is 0 tails. So your x is 0, 1, 2. Okay, so we have the table. This is for px equals to x, 1, 2. Okay, so this is our x. This is px equals to x, which is our probability. So here is tail equals to 0, tails equals to 1, tails equals to 2. Okay, so now we want to count the outcome. So when tails equals to 0, which is 2 heads here, so that will be 1 over 1, 2, 3, 4, 1 over 4. So the probability is 1 over 4. If got 1 tail, we have 1, 2. So 2 over 4. That will be 2 over 4. And 2 tails, we have 1 over 4. Okay, alright. So that is how to represent our probability by using table. So if we want to use a function, let's see how function. So we have px equals to x, the piecewise function. So as you can see, the probability we only have 1 over 4 and also 2 over 4. So for 1 over 4 tu we can kumpulkan dia. That will be 1 over 4, 1 over 2. So for 1 over 4, you have for x equals to 0 and also 2. Okay, kita boleh kumpulkan dia sekali. And this one is for x equals to 1. Okay, so that is how we use function. Okay, if the question said determine the probability distribution table, so you will do this. If the question said find the probability distribution function, so you will do this. If the question said sketch the graph or draw the graph for probability distribution function for x, so what you are going to do is kita lukis graph lah. So you know that the graph for probability distribution for discrete random variable, the graph will be looking something like histogram kan. So dia akan jadi bar-bar lah. So we have 0, 1, 2. So for 0 here, and let's just put our probability. The lowest one, 1 over 4. Here is 1 over 2. When x equals to 0, our px is equals to 1 over 4. Okay, so here. When x equals to 1, our px equals to x is equals to 1 over 2. And this one is 1 over 4 as well. Okay, so that is what our graph will be looking like. Alright, so next one. Hence, show that x is a discrete random variable. So as I said earlier, if the question said show that the graph is discrete random variable, we have to show this. Okay, which is the summation of the probability is equals to 1. So what we have to do here is, let's just change the color. Here we have summation of px equals to x. So we have x until 2. This one is I equals to 0 up until 2 is equals to, so when x equals to 0, we have the probability 1 over 4. When x equals to 1, we have probability 2 over 4. And the last one is 1 over 4, which is you count that, you will get 1. So since we have to do the conclusion, since the question said show, since summation of px equals to x, I equals to, let's just put 1 up until k is equals to 1. Hence, x is a discrete random variable. Okay, so now you learn 3 things. Represent your probability by using function, table, graph, and show discrete random variable. Okay, make sure you have to master this part first before we moving on. Okay, example 2. A fair dice is thrown. If x represent the number on the dice, okay, 3 things you have to do, you have to identify before you do the questions is this one, discrete random variable. If x represent the number of the dice, so this is your x. Number of the dice. Okay, so this one is actually probability distribution lah. Okay, if the question obviously said a fair dice is thrown. Okay, bila dice thrown, number on the dice will be x equals to 1, x equals to 2, x equals to 3. Okay, they're countable. And then the question said find px less than 3 and px between 1 and 5. So what you have to do here first is kita represent data kita dulu, outcomes kita. So let's just quickly do the table. Okay, so here we have 1, 2, 3, 4, 5, 6. Okay, so the outcomes, obviously you have 6 numbers and the outcome only, the number is only 1. So all of the outcomes will be 1 over 6. All of the probability will be 1 over 6. 1 over 6, 1 over 6. Okay, so that is your probability distribution table. So the question said find, okay, first the question asked to show that x is discrete random variable. So as before, the summation of px equals to x when r equals to 1 up until 6 is equals to, we sum up all 1 over 6, 1 over 6, 1 over 6, 1 over 6. Okay, we have 1, 2, 3, 4, 5, 6, and obviously we'll get 1. Okay, then do our conclusion. Since summation of I equals to 1 up until k, px equals to x is equals to 1. Therefore, x is a discrete random variable. Okay, so kita dah show. The next question asked to find px less than 3. Okay, so px less than 3. So know that the discrete random variable they kena equal. Okay, which is just seketul. When we have px less than 3, obviously 3 is not included. So that means 2 and also 1. Okay, so px equals to 1 plus px equals to 2. So here we have 1 over 6 plus 1 over 6. And that will be 1 over 3. Okay, the next one we have p is between 1 x 5. 5 not included, 1 not included. So that will be 2, 3, 4. Okay, just sum up everything. Px equals to 2 plus px equals to 3 plus px equals to 4. So we have 3, 1 over 6, 1 over 6, 1 over 6, 1 over 6, and that's going to be 3 over 6, and that will be 2 over 3. Okay, so you know how to find the probability now. Okay, now let's see next example. The probability distribution function, first thing is discrete random variable. Second thing is probability distribution function. Next thing is what is x. So here we don't have any events, we don't have any experiment. This question just said x is given by this. Okay, so we have px equals to x equals to k 4 minus x. For x equals to 0, 1, 2, 3. Given that k is a constant, find the value of k. So now, let's do our table first. Table is the easiest way to represent our probability distribution. Okay, so we have our x here, px equals to x. So here we have 1, 2, 3, 0, 1, 2, 3. Okay, so for 1, 2, 3, 4. So 0, 1, 2, 3. Okay, now let's just substitute 0 into this one here. So you will get 4 minus 0 is 4, so that will be 4k. If we substitute 1, that will be 3k. If we substitute 2, that will be 2k, and here will be k only. Okay, now we want to find k, constant k. How are we going to find that? One more thing, for summation of px equals to x equals to 1, if the question said find the constant, find constant in the probability or in the table or in the function, this is what you have to do. Okay, so we just sum up. So we know that summation of the probability Px equals to x is equals to 1. So we sum up everything for k plus 3k plus 2k plus k is equals to 1. So 7, 9, 10. 10k equals to 1. So we have our k equals to 1 over 10. Okay, so one more use of this definition here, summation of all probability is equals to 1, is to find the constant. Okay, one is to show the discrete random variable, and second is to find the constant in the function or in the table. Okay, let's see next example. Random variable x has the following probability distribution. Okay, probability distribution. If you see probability distribution, obviously it is the discrete random variable, because for continuous there will be probability density function. Okay, I will explain later what's the difference between those two. So, and actually if you look at your function here, we have, this is the symbol px equals to x. So this actually represent PDDRV. Okay, probability distribution discrete random variable. Okay, first question, determine the value of k. So how are we going to determine the value of a constant? Baru je buat tadi? Correct. Apa yang correct? Tak tahu. Okay, kita akan guna summation of px equals to x is equals to 1. Okay, so we know that summation of px equals to x is equals to 1. So now what we have to do is sub all the x's here into the function, which is the first one we have sub 1 into kx. We have k plus 2k plus 3k plus 4k plus 5 into this. 10 minus 5 is 5, so we have 5k, and then sub 6, 10 minus 6, that will be 4k, and the last one 7, 10 minus 7, we have plus 3k. This all is equals to 1. Okay, so sum all of this will be 22k equals to 1. So your k is equals to 1 over 22. Okay, so remember, if the question asks to find the constant, this is what you have to do. Okay, summation of px equals to x is equals to 1. Okay, now the second one, second question, question B, construct a probability distribution table. So the question wants a table. So let's do the table. Okay, so how many x do we have? 1, 2, 3, 4, 5, 6, 7. So 7 column there. Here we have 3, 3, 1, 2, 3, 4, 7 column. And this is our x. This is px equals to x. Okay, so what we have to do here is just, this one is k, sub k into here, we have k, so your k is 1 over 22. So this one is 1, 2, 3, 4, 5, 6, 7. Basically just sub k into all of this. So 2k times, 2 times 1 over 22, so that will be 1 over 11. And here we have 3 over 22, 2 over 11, 5 over 22, 2, 11, 3, 22. Okay, let's say for 7, k is 1 over 22, 10 minus 7, you'll get 3 over 22. Okay, just sub your k here. Okay, so that is our table. Finish. So the next question, find px greater than 2. Remember, you are doing discrete random variables. So dia kena seketul. X equals to what? X equals to what? X equals to what? So the question said x greater than 2. If you look at your table, 2 is not included. So all of this, we have to sum up everything. So that will be px equals to 3, px equals to 4, px equals to 5, px equals to 6, px equals to 7. Okay, so sum all the probability will be 3 3 over 22, 2 over 11, 5 over 22, 2 over 11. Betul ke ni? 3, 4, 5, 6. Okey, betul. 3 over 22 equals to 19 over 22. Alright? Okay, so one more ways to do this type of question. You are going to learn this more in the next part, but I just want to explain here. Instead of kita tambah, contohlah kita ada sampai 20, x kita 20. So you're not going to put plus this one plus 8, 9, 10, 11 sampai ke 20. Okay, so there are shorter way to do this. You know that the total probability, all things here, all of the sum of the probability is equals to 1. Okay, so 1, we want this part. Okay, x greater than 2 is this part here. So what you're going to do is the sum 1 minus by this part here. Okay, so 1 minus by px equals to 1 minus px equals to 2. So you'll get the same answer. 1 minus 1 over 22 minus 1 over 11. You'll get the same answer as 19 over 22. Okay, so this is one way. This is another way to do it. Okay, total is 1. We only want this part. Sorry, we only want this. Total is 1. We only want this part. So we minus by this part. So 1 minus by this part, you'll get this part. Okay, next one is x equals to 4, x equals to 6. Very simple, very straightforward. X equals to 4 is 2 over 11. Or is plus x equals to 6 is 2 over 11, and that will be 4 over 11. Okay, one more definition that you have to know is the modulus one. P modulus x minus 2 less than 1. So the definition is x minus 2 is between negative 1 and 1. Okay, please remember this definition of your modulus. So here we just pindahkan, and that will be negative 1 plus 1 is 1. Here we have our x, here is 3. So x is between 1 and 3. 1 not included. 1 not included. 3 is not included. So we only want x equals to 2. So px equals to 2, and that will be 1 over 11. Okay, a bag contains 4 pieces of red towels and 3 yellow towels. So we have red, 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 4 yellows, and we have 3 yellow, 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 yellow. Okay, so the question said the towels are to be drawn at random one by one without replacement. So you already know how to do the without replacement thing kan, by using tree diagram. But for this one, kita ada cara lain. From the back until a piece of red towel is obtained. So that is the last thing that we have to do. We have to draw the towel until we get red, then that's enough. Okay, until a piece of red towel is obtained. So what is our x? X is the total number of towels drawn from the back. Okay, so let's say the first one, the first towel that we take, kita terus dapat red. Okay, kita terus dapat red. So that will be P red. So the probability of red, you have 1, 2, 3, 4 red. How many towels do you have in the bag? We have 7. Okay, so that is the probability that the first draw is red. Okay, let's say if the first draw you'll get yellow. Okay, and only the second draw you'll get red. So that will be yellow, red. Okay, so what is the probability to get yellow? Yellow, you have 3. The towel in the bag is 7. Okay, you already take out this one here. Okay, so we already take out the yellow here. So how many towels in the bag? 1, 2, 3, 4, 5, 6. We have 6 towels. So how many red in there? We have 4. So that will be 4 over 6. And here we have 2 over 7. Okay. So now, And also maybe the first towel you draw is yellow, second towel you draw is also yellow, but you cannot stop because the question said until a piece of red towel is obtained, and only at the third draw you'll get red. So that will be P, yellow, yellow, red. Okay, so probability to get yellow is the same thing. We have 3 yellow, total towels in the bag is 7, times by, we take 1 yellow, so total towel in the bag is 6. And the second towel is yellow, also yellow. So how many yellow do we have? 2 here. Okay, so we take out the second yellow, and the third towel is red. So how many towels do we have in the bag? 1, 2, 3, 4, 5. So total is 5. And how many red do we have? We have 4 red. So if we multiply this, you'll get 4 over 35. And the last one, we take yellow, 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 and then only we'll get red because yellow dah habis kan, ada 3 je yellow. So we have P, yellow, 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 red. So the first yellow is 3 over 6, the second yellow is 2 over 6, and the third yellow, if we take this one here, the only the total towel in the bag is 5, and if we take 1 here, we only have 1 yellow, so 1 over 5, and the red one is 4 over 4. So here we have 1 over 35. Okay, alright, so that is the probability that the total number of towels drawn from the bag. Okay, so obtain the probability distribution of X. Okay, the question doesn't say function or table of graph, so it's up to you. Let's just draw a table, it's easier. How many X do we have? What is our X? It's actually number of towels do we have. So we have 1 towels, 2, 3, 4 towels. So we have 1, 2, 3, 4. 1, 2, 3, 4. Okay, 1 towel is 4 over 7, 2 towels is 2 over 7, 3 towel is 4 over 35, 4 towels is 1 over 35. Okay, make sure you sum all the probability, that should be 1. Okay, kalau tak satu maksudnya salah lah kira. So next, the second question, find probability of X between 1 and 3 included. Okay, so 1 is not included, so padam 1. 3 is included, so kita padam sebelah 3. So that will be Px equals to 2 plus Px equals to 3. So that will be 2 over 7 plus 4 over 35, and that will be 2 over 5. And the last one, draw a graph for the probability distribution of X, hence find mode. So the graph for probability distribution for discrete random variable, kita akan representkan dalam bentuk histogram. Okay, so the lowest probability is 1 over 35, and then we have 4 over 35, and then we have 2 over 7, and the highest one is 1 over 7. Here we have 1, 2, 3, 4. Okay, so just draw your graph. X equals to 1, Px equals to X is 4 over 7. Where is your 4 over 7? This one should be 4 over 7. Okay, so up until here. So when X equals to 2, Px is 2 over 7. When X equals to 3, dekat sini. And the last one is here. Okay, so the question said find mode. Macam mana nak cari mode? Kita tengok yang the highest one lah. So the mode is equals to